Up to this point in our course, our focus has been on formalizing deductive arguments using the tools of truth functional logic in particular. But we're now going to shift our focus to studying methods for formalizing inductive arguments, in particular by using probability. So in this lesson, we're going to review the distinction between deductive and inductive arguments, and review the standard for evaluating inductive arguments, and then talk about probability as a measure of inductive strength. Remember from our first lesson that we distinguish between these two broad types of arguments, inductive and deductive, by the degree of support the premises offered for the conclusion. So with the deductive arguments, the truth of the premises guarantees the truth of the conclusion, and with inductive arguments, the truth of the premises makes the conclusion more likely to be true. That's the key feature of inductive arguments. If the premises are true, the conclusion is more likely to be true, but the truth of the premises does not guarantee the truth of the conclusion. This means a couple of things. Inductive arguments may be weakened by new evidence that makes the conclusion less probable given the premises. And furthermore, inductive arguments can be defeasible. That is, by introducing new information, it's possible to completely undermine any support the initial evidence offered for the conclusion. Remember, too, that it isn't the content that determines whether an argument is deductive or inductive. Instead, it's the form of the argument and the degree of support the premises are intended to offer for the conclusion. So here are a couple of examples to contrast. Premise 1, the seedlings were eaten by a skunk or a sparrow. Premise 2, the seedlings weren't eaten by a skunk. Conclusion, the seedlings were eaten by a sparrow. This first one you should recognize as taking the form of a disjunctive syllogism. We've got an or statement, the negation of one of the disjuncts, and from that we infer the other disjunct. That's a deductively valid argument. We can contrast that argument with the one that follows. The seedlings were eaten by a skunk or a sparrow. Skunks prefer to eat grub or fruits. The seedlings were eaten by a sparrow. In the second argument, the truth of the premises doesn't guarantee the truth of this conclusion, that the seedlings were eaten by a sparrow. But what's interesting about this inductive argument is that it does better represent the kind of explanatory reasoning we tend to run through when we have limited evidence and have to come to a conclusion. So while deductive arguments do represent a lot of our simple reasoning steps, inductive arguments often represent better the kind of reasoning we actively do under uncertain evidence. A good deductive argument was one that was valid, and invalid arguments were our bad deductive arguments. For inductive arguments, our standard for evaluation is strength. Inductive arguments offer either strong or weak support for their conclusions. So contrast the following two inductive arguments. Fossil records of later tyrannosaurs did not show evidence of feathers, so not all tyrannosaurs were covered in feathers. Unicorns and bears were both described in medieval bestiaries. Bears exist, so unicorns exist. Without offering much explanation, I think it's pretty easy to see that the first of these arguments is one where the premise offers stronger support for its conclusion than in the second argument. How strong an inductive argument is depends on how improbable it is that the conclusion is false when the premises are true. So a weak inductive argument is one where the truth of the premises makes the conclusion somewhat more likely to be true. Or put alternatively, one where it's probable that the conclusion is false even when the premises are true. Whereas a strong inductive argument is one for which the truth of the premises makes the conclusion substantially more likely to be true. That is, if the premises are true, it's quite probable the conclusion is also true. And here we begin to see that probability can be used as a measure of the degree of evidential support the premises offer for the conclusion. This is what's going to motivate our upcoming study of probability as our tool for formal inductive reasoning. So for deductively valid arguments, since the truth of the premises guarantees the truth of the conclusion, the probability of the conclusion being true given that the premises are true is 100%. That's not going to be the case for inductive arguments. The premises make the conclusion more likely to be true, but they don't guarantee it. So if the premises are true, the conclusion is going to be more likely to be true, but less than 100% likely and more than 0% likely. Note that it follows from these characterizations of the probability of the conclusion given the premises that all inductive arguments, regardless of their strength, are deductively invalid. That doesn't mean they're bad arguments, it just means that our standard for evaluating them has to be different. And to sum up our relation of probability to the premises, if the conclusion contradicts its premises, then its probability is going to be 0%. It's going to be important that we're going to evaluate the strength of our inductive arguments independently of the truth of their premises. So just as we separated validity from soundness, we're going to do the same for inductive arguments. Our focus is going to be on the degree of support the premises offer for the conclusion. So we're going to leave judgments about the truth of the premises to other disciplines. So let's look at this example. Unicorns have been observed to have features that resemble other mammals. They have a head and body that resemble a horse, cloven hooves like a goat, and a tufted tail like a lion. So unicorns are mammals. I think we can be pretty confident that unicorns don't exist. But still, it seems like if those premises were true, they would offer at least a decent degree of support for the conclusion that unicorns were mammals. It's that conditional evaluation that's important to evaluating the strength of inductive arguments. We also have to evaluate the strength of the argument independently from the simple question of how likely the conclusion is to be true. So even if you think the conclusion is likely, it's important to remember that your job is to ask, when evaluating arguments, how likely is the conclusion to be true if the premises are true? And with that, you should now have a basic sense of the role that probability is going to play in evaluating the strength of inductive arguments. And the rest of this lesson will further familiarize you with some basic types of inductive arguments and introduce you to some concepts that will be fundamental to understanding probability, since that's going to be our core tool for representing and evaluating the strength of these inductive arguments going forward.